All right, in this lesson, we're going to be talking about categorizing different numbers. This chart right here should look familiar to us because we created it on a half sheet during one of our first lessons during this chapter. So we have our natural numbers or our counting numbers, which is this small circle right here. These are the numbers that we said you naturally start counting at. 1, 2, 3, 4, all the way up into infinity. Our whole numbers, the second one, are 0, 1, 2, 3, 4. So our whole numbers now include 0. They're also only positive. Our next one is integers. Integers are negative and positive whole numbers. So you have -3, -2, -1, 0, 1, 2, 3, 4, and so on. It goes all the way from negative infinity till positive infinity. Our next category is our rational numbers. The definition that we used for rational numbers was numbers that can be written as a fraction. So we have 1/2, 45 hundredths, 18%. We have our repeating decimals, and we have negative fractions. This also includes -1, -5, 0, 2, 3, and so on. Our irrational numbers are going to be our numbers over here that cannot be written as a fraction. So we cannot write pi as a fraction because it never ends and it never repeats itself, as well as this decimal and the square root of 3. In example 1, we already talked about naming all the sets of numbers which the real number belongs to. So we have this decimal right here. We can say that this is 0.25 repeating, and we know that we can write repeating decimals as fractions, so we know that this is a rational number. It is not an integer because it is not a negative or positive whole number. So the only one that we can say that it belongs to is real and rational. For number 1. For example 2, we have the square root of 36. The square root of 36 actually equals 6. So we could write 6 as a fraction because we could write 6 over 1. So we know it is a rational number. We know it is an integer because it's a positive whole number. We know that it is a whole number because we can count to it. And we know that it is a natural number because we naturally count to 6. So those are all the categories that this belongs to. However, our most specific is our natural number. On example 3, we have the negative square root of 7. If you type this into a calculator, you're going to get this decimal right there. You can see that that decimal never terminates, which means it never stops, and it never repeats itself. So since it is not repeating or terminating, we know that we cannot write it as a fraction. Therefore, the only category it belongs to is irrational. And that is the most specific that we can be. In our guided practice on page 92, I'm going to do a couple of these examples. Number 1, we need to name all of the numbers to which the real number belongs to. So again, we have a decimal here, and we can see that this decimal is actually 0.05 with the 0 and 5 repeating itself. So it is a repeating decimal, and we know that we can write repeating decimals as fractions. Therefore, this is a rational number. It is not an integer because it is not a whole number. So then we would say the most specific is just a rational number. Number 2, the negative square root of 64. The square root of 64 is 8, and it's the negative of it, so negative 8. We know that this is a rational number because we can write it as a fraction. It is also an integer because it is a negative whole number. But it is not a whole number because it is not 0 or positive. So the most specific we would say is an integer. Number 3, if we typed in the square root of 17 into our calculator, we would get 4.1231056, and it keeps going. We can see that it doesn't terminate, and it never repeats itself. Therefore, we cannot write it as a fraction, and the only option we have is irrational. Since it is irrational, it cannot be any of the other things, so it is most specific irrational. On number 4, we are going to fill it in with less than, greater than, or equal to make the statement true. We can use our calculators for this. If we typed in the square root of 15 into our calculator, we get 3.87298, and it keeps going. And we're comparing that to 3 5/10. So we can see that our 3's are the same, or our whole number. So we have to look at the next place value. In the 10th spot, we have an 8 and a 5. Since 8 is bigger than 5, we know that this number is larger. In our next example, we have the square root of 2 25/100. And that is 1.5, or 1 5/10. And then we have 150%. So to change my percent into a decimal, I need to move the decimal 1, 2 places. So I get 1.5. 1.5 and 1.5 are the same, so we have equal to. And number 6, if we typed in the square root of 6 2/10, we get 2.4899979, and it keeps going. And then we have comparing that to 2 and the 4 repeating itself. So if we look at our ones place, they're the same. Our tenths place, they're the same. So we go over to our hundredths. And our hundredths place, we have 8 and 4, and since 8 is bigger than 4, we know that this number is larger. On number 7, we're going to order the set from least to greatest. Remember, we need to write them on the number line using our original set. So we have the square root of 5, which is the same as, the square root of 5 is the same as 2.236, and it keeps going on. We need to change 220% into a decimal, so I'm going to move it 2 places, and I get 220% is the same as 2 2/10, or 20/100. Then we have the next one, which is 2 25/100. And then we have our final one of 2.2 repeating. Okay? We can see that our smallest decimal is this one right here, because the whole numbers are all the same. My tens place are all the same, but my hundreds place, I have a 3, I have a 0, I have a 5, and then this one would actually be a 2 as well. So 220% falls right here. My next smallest would be my 2, which is right here, my 0.2 repeating. My next smallest is my 3 over here, so my square root of 5. And then my final one is 2 and 25/100, which falls right here. And I've ordered them from least to greatest.